Hi, in this video, I will be showing you problem number 2 of chapter 3 section 8 from the practice exam 2. A common inhabitant of human intestines is the bacterium E. coli, named after the German pediatrician who identified it in 1885. A cell of this bacterium in a nutrient broth medium divides into two cells every 20 minutes. The initial population of a culture is 40 cells. Find the relative growth rate. Find an expression for the number of cells after T hours. Find the number of cells after 7 hours. Find the rate of growth after 7 hours. Round your answer to the nearest integer. When will the population reach 1,000,000 cells? Round your answer to 2 decimal places. So let's start off with the model for the population. The population model is P of T equal to P at 0, population at time T equal to population at time 0, e to the kt, where k is the relative growth rate. So yeah, it's given now. The bacterium divides into two cells every 20 minutes. So let's convert the 20 minutes to hour. 20 minutes is 20 over 60 hour. So 1 hour equal to 60 minutes. So it will be 1/3 of an hour. So the initial population is 40. 40 becomes, divides into two cells. So every cell becomes two cells. So 40 cells will become double. So it is 40 times 2. So that goes against P of T. Initial population is 40. E to the k, time taken for 40 to become double is 1/3 of an hour. So times 1/3. So you get 80 equal to 40 times e to the k over 3. So if we divide both sides by 40, you get 2 equal to e to the k over 3, or k over 3 equal to ln of 2, or k equal to 3 times ln of 2, or k equal to ln of 2 cube by property of ln, that is ln 8. So the relative growth rate equal to ln 8. So part A answer is ln 8. For part B, the question is asking us to find an expression for the number of cells after T hours. So P of T is in hour, P of 0, e to the kt is the model. So P of T stays as P of T, population after T hours. P of 0 is given to be the initial population, that is 40 cells. E to the k we found out from part A, which is ln 8 t. So that will be 40. E and ln are inverses of each other. So it will become 8 to the power of t. So the number of cells after T hours is given by the model P of T, given by the formula P of T equal to 40 times 8 to the power of T. Part C is to find the number of cells after 7 hours. So number of cells after T hours from part B is given by 40 times 8 to the power of T, where T denotes the number of hours. Then the question is, in this case, is number of cells after 7 hours. Cells after 7 hours is obtained by replacing T by 7, which is 40 times 8 to the power 7. That many cells. You can compute this in your calculator to find out the figure, and then write that. That will be a very big number. You can write that from your calculator. Part D. Find the rate of growth after 7 hours. Rate of growth is the derivative of P of t. So rate of growth is a derivative. So we are going to differentiate 40 times a to the power t, which is p prime t, which is equal to 40. A to the power t derivative is equal to a to the t ln of 8. That is the derivative. So it is the rate of growth after 7 hours. So t must be replaced by 7. So it is 40 a to the power 7 ln 8. That many cells per hour. Part E. When will the population reach 1,000,000 cells? So the question is when. So what is the time taken? How many hours later? The population will reach 1,000,000 years. So P of t equal to 1,000,000. So 1,000,000 has 6 zeros. It's 10 to the power 6. So now we are going to set P of t to 10 to the power of 6. So P of t, which is equal to 10 to the power 6, which is equal to 40 times a to the power t from part B. Now we are going to solve for t. So a to the power t equal to 10 to the power 6 over 40. It's 1 followed by 6 zeros divided by 40. That will be a to the power t. Then now we are going to solve for t. So by taking ln on both sides, ln of a to the t is ln of 10 to the power 6 over 40, or t ln 8 equal to ln of 10 to the power 6 over 40. Dividing both sides by ln t, t will be ln of 10 to the power 6 over 40 divided by ln 8. This will be 4.8698 from your calculator. But in the problem it asks you to answer to 2 decimal places. So it will be 4.87 hours. So the population will become 1,000,000 after 4.87 hours. Here the population of cells. Hope this video